This is a last lecture for this course, and this lecture will be devoted to the so-called Rossler system. It is three-dimensional flow, also very popular. So Lorentz system was discovered first, Gauss in Lorentz system. Rossler was done later, but it's considered to be the simplest three-dimensional flow where chaos can be observed. And chaos emerges in Rossler system in a way different from Lorentz system. It's also very representative system in this respect. So Rossler system is represented by three equations: x dot equals to minus y minus z, y dot equals to x plus a y, and z dot equals to b plus z times x minus c. Let's find equilibrium for this system. So minus y minus z should be 0, x plus a y should be 0, and b plus z times x minus c should be 0. So roots of this system of algebraic equations are equilibrium. And as we see, first two equations are linear, but third one is quadratic, and therefore we should expect up to 2 equilibrium points. From first we got, let's say, y equals to minus z. From here we get x equals to minus a y or to a z. And here finally we can put b plus z times, instead of x we put a z, it will be a z minus c. So this is quadratic equation. From here we can find z, and from others we will find, so again, x, y, z equals to az minus z, where z's are roots of this z. 1, 2 should be equal to c plus minus square root of c squared minus 4ab divided by 2a. Yeah, so we can put it like this. So here is c plus minus the square root over 2a. Here it's minus same expression, and here it's same expression multiplied by a. Okay, let's put it like this. P2, 3, sorry, P1, 2 equal to c plus minus square root of c squared minus 4ab over 2. Here minus c plus minus square root of c squared minus 4ab divided by 2a, and here same expression without minus, c plus minus square root of c squared minus 4ab divided by 2a. So we have two equilibria which exist if c squared more than 4ab. So when at c squared equals to 4ab, we have saddle node bifurcation. And this saddle node bifurcation is quite interesting. It's three-dimensional. So we have, let's say, P1 is called saddle focus, which is combination of unstable focus so we have two eigenvalues which are complex conjugates with positive real part, and one positive one negative real eigenvalue, unstable focus with stable manifold. And second one is node focus, which is unstable focus with unstable manifold. So this at time of origin when c squared slightly above than 4ab. What happens next when c is increasing? So these points so diverge from each other, they go away from each other, and at some point P2 undergoes eventually degenerative Hopf bifurcation. So this is Hopf bifurcation without formation of limit cycles. And what happens to P2? P2 is now, we can call it again saddle node, which is combination of stable spiral with unstable manifold. So okay, so what now? Let's check it. P1, so I will just sketch it how it looks. P1 was combination of stable manifold with unstable spiral. So for example, this is unstable spiral. So here somewhere we have P1. So let's put it like this. So this is X, Y, Z. But there is, on the other hand, stable manifold. So this is P1. P1. P2, it's other way around. So there is stable spiral. So there is convergence here and divergence here. And this combination can result to formation of loops, of limit cycles. So how it works? This goes here, and this goes there eventually. And this way we can get limit cycle. So it results to interaction between equilibrium points with formation of closed phase trajectories. So this kind of limit cycle, it's also forms, it's in interesting ways. It forms because of interaction between two equilibrium. And now when C is increasing, results to formation to change of closed loop, namely we can put it like period doubling. And this period doubling, so I can illustrate it like this, but you can see a couple of figures in lecture notes how it forms. So this, let's say, this is a first loop, so it is like this. Somewhere here, P1, somewhere here, P2. So this is closed loop. And when C is increasing, it can get something like this. It goes something like this. Like this. So here P1, here P2. And so now we have two loops. So it is closed loop, but it makes like 2 rotations. And if C increases, there will be 4 rotations and 8 rotations and so on. And this is period doubling. And this period doubling ends to chaos, same way as in logistic map. So this is second way of formation of chaos in 3-dimensional flows.